Thank you very much for the introduction, Flo. So yeah, I'm Juan Luis Ruiz-Tagle. I'm a data scientist currently working at CARTO, and I'm going to present the Analytics Toolbox, which is something I've been working on together with my team and other teams at CARTO. No? So the title is A Toolbox for Scalable Spatial Data Science in the Cloud. And basically, I'm going to divide this talk in three parts. First, I'm going to give you some context about our new cloud-native platform. Then I will present the toolbox, which is a part of this. And then I will give you some examples about things or features you can do with the toolbox. So the new cloud-native CARTO. So as some of you might know, CARTO last year released a new version of its location intelligence platform, which is now fully cloud-native. Okay, it has been designed from the ground up, to be an extension of the cloud data warehouses for everything that has to do with spatial analytics and visualization. This means that you can do spatial analysis and then directly on top of your data, and then take the output of such analysis and build a very nice visualization in a very intuitive way and highly customizable way. Very easy, with our new platform. This brings three main benefits. Okay, so everything is very scalable if done fully cloud natively. It's very scalable. You're going to run an analysis on terabytes of data in a glimpse very quickly. It's cost efficient. You can separate costs from storage and computation, and is very, very convenient. So, because you don't have to move your data around to do your analysis, you are executing everything on top of your data. You can forget about ETLs and everything. So it's much more easy to use in this sense. No? So right now, this extension is fully supported for four cloud data warehouses. So Redshift, BigQuery, Snowflake, and recently we have added the Databricks, as Milos explained before. So yeah, now I will present the Analytics Toolbox, which, to put it simply, it's basically like a library of sorry, thank you, Flo. It's basically a library of SQL functions that can be installed in your cloud data warehouse. No? This lets you basically execute all the functionality that it provides, which is for spatial analytics, directly on your data with very simple SQL queries. No? These can be executed directly from the CARTO workspace or from your client. No? And we have different levels of abstraction of the things included in this analytics toolbox. So we have a core level, which is open source. It's free to use, and basically lets you do stuff with spatial indexes and geometric transformations, quite handy sometimes. And then we have an advanced module, and so an advanced level of modules and even domain-specific modules. No? So here you have some of the advanced modules. I'm going to focus on a couple of them. For example, the data module right there is basically letting you do geospatial enrichment of data with your subscriptions from the Data Observatory. The Data Observatory is basically CARTO's data marketplace. So you can enrich your tables with your geometries with data from your subscription or other tables as well. There's another module for routing, which lets you generate routing networks and then calculate optimal paths from one point to another one in the network. And there is like a statistic module, which basically has functionality to do spatial statistics and spatial modeling, and so on. No? So these are a couple of the modules, the advanced modules we have, and then the retail module, which is like domain-specific module only for retail-related stuff. So now, in this session, I wanted to present you a couple of the things we have in the Analytics Toolbox. Basically, three functions, so log-and-more and psi, geographically weighted regression, these two belonging to the statistics module. And last, I will talk about revenue prediction, which is a set of functions which is used to make predictions of a new store given some other data. No? We are the data warehouse of choice for this example is basically BigQuery, and the data we're going to use is publicly available dataset called Iowa Liquor Sales Dataset, which gives you, like, I don't know, the location and the revenues of different stores in Iowa, in this state, throughout time. We will use it to take a look at these functions. No? So the first one, local Moran's I. Basically, local Moran's I is used to find the local autocorrelation of a feature, which in this case is the revenue. No? So it basically is answering the question of how similar is a location to the locations nearby. So as you see here, it's very easy to use with like a typical select from SQL statement. You can call the function here. Here you pass the data, and there are other arguments, which are the cring distance and the decay function. Cring distance basically decides at each cell what is the area we are going to consider to calculate the local Moran's I at that cell. No? If it's the number three, we are considering cells of which are at a maximum distance of 3 from the current cell. No? And then the third parameter here is the decay function, which basically tells you how are you going to weight each of the neighbors into the calculation. No? So an exponential decay function gives less weight to the neighbors which are farther away from the current cell than the ones that are closer. No? So here you can see it live, and now in the map, this is basically a computation of the local Moran's I for all the cells in which you can find liquor stores in Iowa. And for example, here, the dark green is basically like where there is a high level of autocorrelation, which means that the revenues of the stores in these cells are very similar. Not necessarily very high or very low, but very similar, no? Independently of the value. And for example, in this other area, we see very, very different levels of revenue in the stores of these cells. No? So basically, if you would only have this information to open a new store, it would be quite risky to open it in this area, no? Because you don't really know what to expect from a store located there in terms of revenue, because liquor stores tend to have very different values. No? Then, geographically weighted regression. So this method is basically a statistical modeling method which is fitting a least squared regression locally at each cell, taking into account the data from that cell and cells which are nearby. No? You define as well like a distance of number of neighbor cells you want to take into account and a decay function. And you then, it's very easy to use. No? You just pass the idea of the table you want to have a source, the regressor inputs, and the target variable. In this case, we are trying to predict profit from revenue and volume of liters of liquor sold at each cell. Then you have other arguments like, which is the geometry of the column, which spatial index are you using, decay function, and so on. No? And if we take a look at the results, okay, well, something I didn't say is basically that this is answering the question, how does the impact of a regressor vary across a space? So we are fitting a linear regression at each cell, which 2 different regressors, and the dependence on the final like variable, the profit, is not going to be equal in every place. So we want to plot the coefficients of these regressors to see how they vary. No? And here we can see the result. No? In the left, we have the coefficient of the revenue in each of the cells in which there are stores, and here is the volume. We can see that the volume tends to be way more, has way more impact in the outskirts of town than the revenue, which it tends to be more important here, no? In the inside. This is probably, this can be interpreted in the following way. So to get the same amount of profit, a venue which is in the outskirts needs to sell a lot of more liters of liquor than a venue which is inside town. No? This is probably because the margin you can get from each bottle. No? You cannot afford, maybe in the outskirts of town, to put a very high price to a bottle. No? And you have to sell a lot more to gain the same profit. So the last set of functions I'm going to explain is the revenue prediction, which basically lets us make predictions of the potential revenue of a store in a new location. Given the data of your own stores, so you know where your stores are located and the revenue of each of them, and you can pass as well data from your potential competitors. It basically has 3 steps, so data preparation, model training, and then predicting the revenue itself. The output of each step is the input of the next one. So we have like 3 functions. Now I'm going to go through all of them real quick. So the first one is basically where you prepare the data. You pass here on top, the first argument is basically, okay, where are my stores and which revenue do each of them have? Then you can pass here another SQL SQL statement which evaluates of where your competitors are. You select an area of applicability, which in this case is basically like the whole Iowa state, and some other parameters like which H3 index you are using, which zoom level, and so on. And you can also enrich all those cells in the area of applicability. You are like in the area of study, you can enrich those cells with variables from your subscriptions, or from other tables. You can enrich them. Here we are making enrichments with population, with retail, financial POIs, tourism POIs, so a set of variables. So the next like the output of that function is basically a table with all that information combined in a very specific way, which we can then feed to the next function, which is model training. You can see that we are passing the table name, and in the background, what this is doing is basically training an XGBoost model, which you can slightly configure. You can pass some parameters there, as you can see, like max iterations and max redepth, and then there are other parameters available. And the output of this function is basically 3 things. The model trained on one side, then a table which contains SHAP values with the feature importance, and another table which has some statistics about the model. Here you can see a plot of the feature importance of each of the features of your model, which sometimes is interesting maybe to show to clients or to someone so that they don't see the machine learning model as a black box, but as something they can more or less interpret. And here we see that the tourism, transportation POIs and population are the drivers of the revenue prediction in this area. And the last step is basically making predictions. So you take the model you have trained, you pass a set of locations to which you want to make a prediction of revenue, and you execute the model and you get the inference values. Here we can see that in the map, basically we can see that so the green dots are the stores which are currently ours with our revenue, and the blue dots are the places in which we have made an estimation, and so on. So some key takeaways from this talk, very shortly. First, I would say that spatial data science at scale is now much more feasible thanks to the integration between data warehouses and CARTO. Then second, SQL is becoming the universal interface to do data analysis on the cloud, becoming the language of choice, basically. And that CARTO is basically developing this analytic toolbox with spatial analysis functions, to be run natively on all the leading cloud platforms. So basically, that would be it. Thank you for listening.
Any questions for Juan Lu about his analysis? Any questions? Yep, on there.
Hello. Every spatial analysis you showed was using H3 index as an input. Is it a requirement, or can you use your own geometries? So let's say you got your data on output areas. You don't want to do the interpolation to H3 because you're losing information. Can you use anything, or is it requiring H3 to build the weights?
So we have, apart from H3, we have available other spatial indexes like Quadkey, but And some of the methods that we have implemented, it's actually a requirement to use a special index because it's the only way we think it's the only way to make the whole thing scalable, to run the analysis on terabytes of data. Whereas sometimes if you make this analysis using custom geometries, it's more difficult, no? But there are some other methods in the analytics toolbox which don't have this requirement necessarily. Yeah.
Another question from this lady here.
Hello. Really interesting. I had a question. So I use CARTO frames, which I know is a function of the kind of old version of CARTO. And I guess in the case of geographically weighted regression, especially there may be a lot of data prep that kind of goes beyond what you can do in SQL. Is there any plans to have functions like that available in CARTO frames? Is it there already?
So right now, I would say that CARTO frames is a little bit like in a frozen state. I know there are plans to like further develop or make like a new version of in the future, but like well, it's a little bit on the air. But right now, there is like no direct support for this kind of functionalities in CARTO frames. Although you can always execute you can execute these functions, and then the output you can plot it very easily with this package, no? But not for now.
Cool. Okay, I think, one more question over here.
My question is similar to the previous question in that some of the methods like conditional autoregressive modeling are commonly used for modeling autocorrelated data and spatial data. Have you guys thought about including that to add value to the tools that you already have?
So could you repeat again the kind of modeling you were mentioning?
The conditional autoregressive modeling that seems to be commonly used with spatial data, and it's something that would really add to the tools that you have.
So in our backlog, there is like a set of functionalities we want to add to the Spatial extension, and like there's quite a lot of them. Right now, I'm not sure if this these kind of models, the autoregressive models, are included, but definitely is something to think about and to consider. Yeah.
Awesome. Thank you. I'm going to have to keep going to the next one, but feel free to have a chat with this gentleman afterwards who has a question. Thank you so much, Juan Luis, for joining us. Well done.